Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 9 Matrices. We will understand all the concepts of matrices with examples and solve more questions from exercise 9A. Are you all ready? Let's start. Let us first understand the basic idea of what a matrix is. Where does a matrix help us? We will begin with an example. We are considering three children A, B and C. Okay. A has 4 pens and 2 pencils with him. Okay. A has 4 pens and 2 pencils. This is a statement. Now B. B has 8 pens and 7 pencils. Also, C has 5 pens and 3 pencils. Okay. These are 3 different statements. A has 4 pens and 2 pencils. B has 8 pens and 7 pencils. C has 5 pens and 3 pencils. To simplify this, I can give a tabular representation of this. Yes. So, this is a tabular representation. Here we have the name of the students A, B and C. Okay. In the second, we have number of pens. A has 4 pens, B has 8 pens and C has 5 pens. What about the third? Third, we have pencils, number of pencils. Here A has 2 pencils, B has 7 pencils and C has 3 pencils. This is a tabular representation. When this statement is converted into a tabular representation, just by looking at this table, we can understand what A has, what B has and what C has. A more simple representation is the matrices. Okay, matrices are always represented in square brackets. Okay, we use square brackets to represent matrices. Inside these square brackets, we can add the numbers or alphabets or the functions. Here we have number of pens 4. Number of pencil with A, it is 2. Number of pens with B, 8. Number of pencils with B, 7. Number of pens with C, 5. And the number of pencils with C is 3. So, this is a matrix representation. Here I am naming this matrix as M. Inside this matrix, we have numbers filled. Okay. Here, this is the first row. Here, this is the first row. We will call it R1. This is the second row, R2. And this is the third row, R3. What is R1? R1 gives us what? A has 4 pens and 2 pencils. What about R2? R2 gives information about what B has. B has 8 pens and 7 pencils. What about the third row R3? R3 gives us information about what C has. C has 5 pens and 3 pencils. Okay. Now come to the columns. This is our first column. I will call it C1. And this is the second column, which is C2. What is C1? C1 gives information about the number of pens each child has. A has 4 pens, B has 8 pens and C has 5 pens. This is what given in the first column. Now check the second column. This is our second column, right? What is given in the second column? Number of pencils that each child has. A has 2 pencils, B has 7 pencils and C has 3 pencils. That is 2, 7, 3. Okay, understood? This is a matrix representation. Matrix is always represented inside a square bracket. These are the contents. Here we are filling it with numbers. So, matrix is a rectangular arrangement of numbers arranged in rows and columns. Here we can see 3 rows and 2 columns. Here this is a rectangular arrangement, right? This rectangular arrangement of numbers in rows and columns are called matrix. When it comes to matrices, matrix is the singular form and matrices is the plural if you have a number of matrices. Okay, if you have matrix A, matrix B, matrix C, then together we can call them matrices. Singular representation is a matrix. Here M is a matrix. Okay. Clear? Understood what a matrix is? Now let's understand what elements of a matrix are. In our previous example, we had M is equal to 4, 2, 8, 7, 5, 3. You know what these numbers are, right? So these numbers are called the elements of the matrix. Okay? These are the elements of the matrix. That is, the members or the components of the content of the matrix are called elements of the matrix. Now when you take this example, here we had 6 members, right? We have 6 elements in this matrix. I will be giving you an example. 1, 2, 3, 4. Okay. We can represent this in different matrices. I am taking a matrix A. A is equal to 1, 2, 3, 4. Here what is the case? We have 4 rows and 1 column. 1 column. Okay. Rows, they are horizontal, and columns, they are vertical. Remember, this is row. These are rows. Okay. These are columns. Now, the same matrix can be represented in a different form. B is equal to, I will be taking 1, 2, 3, 4. Here what is the difference? In this case, what is the number of rows? Here there is only 1 row. Therefore, number of rows is equal to 1. What about the number of columns? Columns is equal to first column, second column, third column and fourth column. C1, C2, C3, C4. We have 4 columns. That is, the 4 elements are represented in 2 matrices, right? Here 1, 2, 3, 4 are the elements. In the first matrix, they were represented in a form where there are 4 rows and 1 column. In the second matrix, they are represented in a form where there is 1 row and 4 columns. Now another representation. 4 elements should be filled. I am filling them as a matrix C is equal to 1, 2, 3, 4. This is also possible. Here what is the case? In this case, we have, this is our row 1, this is row 2. This is column 1, column 2. Okay. In the first row, what is the number of elements? In R1, we have 2 elements. What about R2? In R2 again, we have 2 elements. Now check the columns. In C1, we have 2 elements. C2 again, we have 2 elements. 2 and 4 are the elements of C2. Here again 2 elements. So in the first matrix A, we had 4 rows and 1 column. In the first row, we had 1 element. In the second row, 1 element. Third row, 1 element. Fourth row, 1 element. What about columns? There is only a single column. In the single column, we have 4 elements. When it comes to the second matrix, we represented the 4 elements in a matrix B. We had 1 row. The row contains 4 elements. And columns, there are 4 columns and each column contains 1 element. Again, we represented the 4 elements in another form, that is matrix C. Here, 1 and 2 belongs to first row. These are the 2 elements of first row. 3 and 4 are the elements of second row, 2 elements. Okay. When you check the columns, in the first column again we have 2 elements, 1 and 3. In the second column, 2 and 4 are the elements. Now, can I represent in this form? A matrix D is equal to 1, 2, 3, 4, 5. We have 5 elements and I am representing in this form. Is this possible, do you think? No, this is not possible because here we have a blank. This cannot be filled. So, if there are 5 elements, in that case, we can represent either it as like this. 1, 2, 3, 4, 5 or as in a matrix F is equal to 1, 2, 3, 4, 5. We cannot represent in this form because here we have no element in this position, which is not possible. Remember these things. Now understood what elements are? How the elements are filled in rows and columns in a matrix is understood now. Okay. Next, let's understand what order of a matrix is. Let us take a previous example. Matrix M is equal to 4, 2, 8, 7, 5, 3. In this example, we know the number of rows and number of columns. This is our first row R1, this is R2, this is R3. Okay. Here we have the first column C1 vertical, second column C2. Therefore, number of rows, what is the number of rows? 1, 2, 3 is equal to 3. Number of columns. Number of columns is equal to 1, 2. Okay. To get the order of matrix is represented as 3 by 2. Here this cross mark represents by. 3 by 2. That is number of rows by number of columns. Okay. Number of rows by number of columns. This is the order of a matrix. Now, the general representation of the order of a matrix is, will be taking the number of rows some m and the number of columns as n. Then we can represent the order of matrix as m by n matrix. Okay. Order of the matrix is an m by n matrix. Now, what is this? Here we have 3 rows and 2 columns. This is a 3 by 2 matrix. Okay. You are using cross. This is not multiplication. This means by. 3 by 2 matrix. Another example. Here we have a chessboard. Okay. In this chessboard, what are the number of rows and number of columns? This is R1, R2, R3, R4, R5, R6, R7, R8. What about the number of columns? This is C1, C2, C3, C4, C5, C6, C7, C8. Here we have 8 rows and 8 columns. Number of rows and number of columns are same in this case. Now, what is the order of this matrix? Order will be equal to 8 rows and 8 columns. Number of rows into number of columns. Here m value is 8 and n value is also 8. So, this is a 8 by 8 matrix. Okay. Here this is the first element. First element means it belongs to the first row and first column. Second element belongs to the first row and second column. Third element belongs to the first column and the second row. Fourth element belongs to the second row, second column. Fifth element, here is the fifth element belongs to the first column and third row. Here we have the sixth element, it belongs to the second column and the third row. Got it? We have used a chessboard. In the chessboard, we have 8 rows and 8 columns. Therefore, the order can be written as 8 by 8. Got it? If I give you another matrix, matrix P is equal to 1, 2, 3, 4, 5, 6. In this case, what is the order? How can you find the order of this matrix? First, check the number of rows. What are the number of rows here? Number of rows is equal to, this is the first row, R1, this is the second row, R2. Then what is the number of rows? Number of rows is equal to 2. Now check the number of columns. How many columns are there? Here, this is the first column C1, C2, C3. Therefore, number of columns is equal to 3. Then what is the order? 2 rows and 3 columns. Order will be 2 by 3. Number of rows by number of columns. Understood? Now, if you get any matrix, you can find the order, right? Yes. Next, we'll understand different types of matrices. There are many different types of matrices. Consider this classroom. You know, inside a classroom, students are arranged in rows and columns. The students belonging to the first bench, that is first row. Second bench, second row. Third bench, third row. Also, they are arranged in columns. There are first column, second column, third column. Here, this is the first row, R1. This is second row, R2. Here we have first column C1, second column C2, third column C3. Okay, now let's understand what row matrix and column matrix are. What is a matrix? We know matrix is a rectangular arrangement of numbers. Here I am taking a matrix M. M is equal to 1, 2, 3, 4. Okay. Here what are the number of rows? Number of rows is equal to, there is only a single row R1. Okay, is 1. What about the number of columns? Number of columns is equal to 1, 2, 3, 4. 4 columns. What about the order? What is the order of this matrix? Number of rows by number of columns. 1 by 4 is the order. In this case, here we know the number of rows is equal to 1. So, a matrix which has a single row. Number of columns can be plural. That is, it can be any number of columns, but the number of rows should be 1. Only a single row. In that case, we call the matrix as a row matrix. If the number of rows is equal to 1 and the column number can either be 1, can be 2, 3, 4, etc., the matrix is called a row matrix. Then what about column matrix? We are taking another matrix B. B is equal to 2, 8, 4, 7. In this case, what are the number of rows? Rows is equal to first row R1, second row R2, third row R3, fourth row R4. We have 4 rows. What about the number of columns? Number of columns is equal to, there is only a single column in this case, C1. Yes? So, here the number of columns is 1. If row matrix is a matrix in which there is only a single row, then a column matrix will be a matrix in which there is only a single column. The number of rows can be plural. It can be 2, 3, 4, etc. But the number of columns should be 1. In that case, we call it a column matrix. Understood row matrix and column matrix? Row matrix, single row. Column matrix, single column. So, we understood row matrix and column matrix. Next is square matrix. We have taken the example of a chessboard earlier while studying the order of matrix. What was the order of the matrix? It was an 8 by 8 matrix. Yes, 8 rows and 8 columns. We represented that R1, R2, R3, etc. up to R8. C1, C2, C3, etc. up to C8. So, this is an 8 by 8 matrix. What is the speciality with this? Is it necessary that the number of rows and number of columns should be equal in a matrix? No, right? It can be an m by n matrix. Number of rows and number of columns can be different. But when the number of rows becomes equal to number of columns, in that case we call it a square matrix. Okay, a matrix A is equal to 1, 2, 3, 4. Here, what are the number of rows? This is first row R1, this is second row R2. This is the first column C1, this is second column C2. Here we have 2 rows and 2 columns. That is, this is a 2 by 2 matrix. In that case, we have the number of rows is equal to number of columns. This is a square matrix. Next, matrix B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. We are taking some random examples. Okay. Here we have number of rows R1, R2, R3. What about columns? C1, C2, C3. In this case, number of rows by number of columns 3 by 3. Number of rows is equal to number of columns, and this is also a square matrix. A square matrix, a matrix with equal number of rows and columns are called square matrix. Understood? So, this is a square matrix of order 2 by 2. A is a square matrix. B is a square matrix of order 3 by 3. And here this chessboard, this is a square matrix of order 8 by 8. Clear? Next, rectangular matrix. We said in square matrix the number of rows and number of columns are equal. When it comes to rectangular matrix, what is a rectangle? In a rectangle, if all the sides are equal, that is the length and breadth are equal, then it becomes a square, right? So, a rectangular matrix is one in which the number of rows is not equal to the number of columns. For example, matrix M is equal to 1, 2, 3, 4, 5, 6. Here, what are the number of rows? First row. This is first row R1. This is second row R2. Number of columns? This is first C1, C2 and this is C3. Here we have 2 rows and 3 columns. The matrix is of the order 2 by 3. 2 rows, 3 columns. The number of rows is not equal to number of columns and hence it is a rectangular matrix. A matrix in which the number of rows not equal to the number of columns. Another example, we'll take P is equal to 8, 0, 5, 3, 2, 1. Number of rows, here the number of rows 1, 2, 3, horizontal. We have 3 rows, number of columns 1, 2. This is a 3 by 2 matrix. P is a 3 by 2 matrix and it is a rectangular matrix because the number of rows is not equal to the number of columns. Clear? Next, 0 or null matrix. A matrix in which all elements are 0. Okay, this is a 0 matrix or null matrix. Usually we represent it with letter O. Capital letter O represents a null matrix or 0 matrix. The elements should be 0. This is a 0 matrix. 0, 0, 0, 0. First, second, third, fourth elements are zeros. The elements in the first row, elements in second row, elements in first column, elements in second column are all equal to 0. This is an example of 2 by 2 null matrix. Then, O is equal to 0, 0, 0, 0, 0, 0. This is again a null matrix. What is the order in this case? Here the number of rows is 3 rows and the number of columns are 2 columns. 3 by 2 null matrix or 0 matrix. Null means empty. The elements are empty, right? Empty in the sense we are using 0 to represent the elements. Then O is equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. This is again a 0 matrix or null matrix of order 3 rows, 3 columns. Therefore, 3 by 3. 3 by 3 null matrix or 0 matrix. Next is diagonal matrix. This is important. A square matrix. We know what a square matrix is. Square matrix is a matrix in which number of rows is equal to number of columns. A square matrix in which all elements are 0 except the principal diagonal elements. Principal diagonal elements are non-zero. Let's check. I'll take an example. A is equal to, I'm taking a 3 by 3 matrix. In this 3 by 3 matrix, the condition is that the diagonal elements should be non-zero. What are diagonal elements? Diagonal, this is the diagonal, right? 1, 2, 3. From the top left to the bottom right. This is a principal diagonal. Okay. In this principal diagonal, the elements are non-zero. And the remaining elements, here, all the remaining elements should be equal to 0. This is what a diagonal matrix is. So, this is a principal diagonal. We have another diagonal. Here, this is a diagonal. If you take a matrix B, B is equal to 0, 0, 0, 0, 0, 0. These are non-diagonal elements. And the diagonal elements, we are taking 1, 2, 3. These are also diagonal. Here, in this case, we need the principal diagonal elements as non-zero. Then it is said to be a diagonal matrix. Understood the concept of diagonal matrix? So, this is an example of a 3 by 3 matrix where we have a diagonal matrix. It is a square matrix. Important thing, diagonal matrix are always square matrix, okay, in which the principal diagonal elements are non-zero and all other elements are equal to 0. For example, if you are taking a 2 by 2 matrix, C is equal to matrix 1, 3, 0, 0. When you check this, this is a principal diagonal. Principal diagonal elements are non-zero and the other elements, non-diagonal elements are equal to 0. Understood the idea about diagonal matrix? Next type of matrix is unit or identity matrix. Let's understand what unit or identity matrix is. We know what square matrix is, what diagonal matrix is. Now, when in case of a diagonal matrix, matrix A is equal to, in a diagonal matrix, non-diagonal elements are 0. If the diagonal elements are equal to 1, in that case we call the matrix an identity matrix or unit matrix. Unit is a word usually used in terms of 1, right? So here when the principal diagonal elements becomes equal to 1 and the remaining elements are 0, in that case we call the matrix a identity matrix. Usually we use the letter I to represent identity matrix or unit matrix. Matrix I is equal to 1, 0, 0, 1. This is a 2 by 2 identity matrix. I is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. This is a 3 by 3 identity matrix. Okay, remember one point, that is identity matrix is a diagonal matrix. Also identity matrix is a square matrix. Already we have diagonal matrix are square matrices. Therefore, identity matrix being a diagonal matrix is also a square matrix. Okay, you cannot have an identity matrix I is equal to 1, 0, 0, 1, 0, 0 or something like that. Why? Because diagonals are not getting complete. In that case, we cannot have identity matrices. Identity matrix should always be square matrix. They should be diagonal matrix and the diagonal element should be equal to 1. Non-diagonal elements 0. Clear? So, we studied the different types of matrices. Row matrix, column matrix, square matrix, rectangular matrix, diagonal matrix, null matrix and unit matrix. Now, we are going to study what transpose of a matrix is. Take our previous example, M is equal to 4, 2, 8, 7, 5, 3. Here we have R1, R2, R3, C1, C2. Okay, 3 rows and 2 columns. When it comes to transpose of a matrix, to find transpose of a matrix, we will be interchanging the rows and columns. And the transpose matrix is represented as M raised to T. Okay, MT, M transpose. This is how you represent the transpose matrix. Now, in this case, we have 3 rows and 2 columns. The order is 3 by 2. When it comes to transpose matrix, the order will reverse. Order will interchange. That is, number of rows becomes number of columns and number of columns becomes number of rows. Therefore, order should be 2 by 3. There should be 2 rows and 3 columns. Now, take the first row. This is the first row. This elements of first row will become the elements of the first column in case of a transpose matrix. That is, here it is 4, 2. 4, 2 will be the elements of the first column. Okay. Now, the elements of the second row, 8, 7 will become the elements of the second column in the transpose matrix. That is 8, 7. Now, the elements of the third row, 5, 3 will become the elements of the third column in the transpose matrix. So, this is the required transpose matrix of matrix M. And the order is, check the order. Here we have first row R1, second row R2. First column C1, second column C2, third column C3. And the order is 2 by 3. This is a 2 by 3 matrix. Got it? Here what happens? The number of rows becomes number of columns and the number of columns becomes number of rows. Every row becomes every column in the transpose matrix. Okay? Clear? This is what a transpose matrix is. Let's take an example. A matrix A. A is equal to 1, 2, 3, 4, 5, 6. What is the transpose of this matrix? Give me answer. The transpose is represented as AT, A transpose will be equal to, what is the first row in this case? This is a 2 by 3 matrix. Yes, 2 rows and 3 columns. Then what will be the order of the transpose matrix? M by N becomes N by M, that is 3 by 2. Transpose matrix will be a 3 by 2 matrix. Now check the elements. Here the first row elements are 1, 2 and 3. Here it becomes first column elements 1, 2, 3. 4, 5, 6 belongs to the second row. Second row elements becomes elements of the second column in the transpose matrix, that is 4, 5, 6. This is A transpose. When you get a matrix A, we can easily find the transpose matrix by interchanging the rows and columns. Clear? Another example, if I am giving you a matrix, B is equal to 1, 3, 5, 2, 6, 1, 4, 5, 3. What is the order of this matrix? Here we have 3 rows, 1, 2, 3. Columns, 1, 2, 3. 3 columns. This is a 3 by 3 matrix. In this 3 by 3 matrix, we are going to find the transpose of this matrix. B transpose. First row becomes first column, second row becomes second column, and the third row becomes third column. What is the order of this matrix? Here 3 rows, 3 columns. Number of rows and number of columns are equal. When you interchange them, again they will be equal, right? This will again be a 3 by 3 matrix. Just we have to change the elements. That is 1, 3, 5, 1, 3, 5, 2, 6, 1, 2, 6, 1, 4, 5, 3. So when you take a square matrix, B is a square matrix of order 3 by 3. When you take a square matrix, the order of the transpose will be the same. Order of transpose will be the same. Okay. Here, by interchanging the number of rows and columns, just the elements are changing. Order will be the same. Because changing them will bring the same order, right? Clear? Equality of matrices. When do we say two matrices are equal? We are taking two matrices, matrix A and matrix B. Okay. A contains some elements and B contains some elements. First thing to check is if the matrices have same order. Here I am going to give you two matrices. The first matrix order is 2 by 3 and the second matrix also the order is 2 by 3. Now we will fill some elements. 1, 2, 3, 4, 5, 6. Okay. Second condition is corresponding elements of the matrices are equal. Here we check the order. We are taking 2 by 3 matrices. Therefore, order is same. Number of rows and number of columns are same. This is a given condition. Now, second point is corresponding elements should be same. Only then these two matrices can be called equal. Then what should be the matrices elements in B? If A and B are equal, if A is equal to B, matrix A is equal to matrix B. In that case, we check the first condition, that is order of the two matrices. This is a 2 by 3 matrix and I have given you that this is also a 2 by 3 matrix. Therefore, the order is same. Now, what to check? The corresponding elements. Here, the elements are not given. If these two matrices should be equal, if they are equal, in that case, 1, 2, 3, 4, 5, 6 should be the elements of B as well. Okay. Here, two condition. First, check the order and second thing, check the elements. Here, the first element. This is our first element. Here it is 1. In B, in this position, we should have 1. Only then, these two matrices can be equal. If at least one element becomes different. Here we have 6 and here if it is 7. In that case, they are not equal. All the elements should be equal. Here the second element is 2. Here the second element is also 2. Then third element is 3. Third element is 3. Fourth element 4. Here also 4. Only if all the elements are equal and order are same, then we call that these two matrices are equal. Therefore, two matrices are equal if matrices have same order, and the second condition, corresponding elements. Corresponding elements means what are the first element, that is the element belonging to the first row and first column, if they should be equal. Then what are the second elements? Second elements means belonging to first row and the second column. First row and second column. Here we have the second element. Here we have the second element in B. They should be equal. Are equal. Only in that case we can call these matrices are equal. Let us take an example to understand the equality of matrices. Here we have two matrices. Find the value of X, Y, A and B. Given that these two matrices are equal. What is the order of first matrix? Here 1 row, 2 row, first column, second column. This is a 2 by 2 matrix. What about this? This is also a 2 by 2 matrix. We check the first condition. They are equal. Order of first matrix is equal to order of second matrix. It is given that they are equal. So, we don't need to actually check. Now, the corresponding elements should be equal because they are equal matrices. X minus 2. This is the element that belongs to first row and the first column. Here, First row and first column we have 0. Therefore, x minus 2 should be equal to 0. If x minus 2 is equal to 0, then what is x? X will be equal to 2. Yes, minus 2 comes here and becomes 2. Now check this element. Here, this is the element of first row and second column. We have y. Now check in this matrix. Here, what is the element that belongs to the first row and the second column? We have 3. Therefore, the value of y will be equal to 3. Next, third element, that is belonging to the first column and the second row. Here it is a by 2. Since these two matrices are equal, a by 2 should be equal to, here we have 1 in the second row and the first column. A by 2 is equal to 1. If a by 2 is equal to 1, then a will be equal to 1 into 2, or a is equal to 2. A is equal to 2. Now, the fourth one, this is the element that belongs to second row and second column in the first matrix, that is b plus 1. What is b plus 1? b plus 1 should be equal to 5, because here 5 is the element that belongs to the second row and second column in this matrix. These two matrices are equal. Therefore, b plus 1 should be equal to 5, or b is equal to 5 minus 1, which is 4. We got the values of x, y, a and b. X is equal to 2, y is equal to 3, a is equal to 2 and b is equal to 4. Got it? If two matrices are equal, then the corresponding elements should be equal. First, when we discussed this, we said that two matrices are equal only if the order of these two matrices are equal and the corresponding elements are equal. Here it is given that these matrices are equal. If these matrices are equal, then the order of the matrices will be equal. Also, the corresponding elements should be equal. We have taken that condition to find the values of x, y, a and b. Okay. Next, we will discuss the algebra of matrices, that is addition and subtraction of matrices. Here I am taking two matrices A and B. A matrix is equal to 2, 4, 3, 5 and B matrix is equal to 1, 3, 6, 2. We are going to add these matrices. First condition to check is both the matrix, the order of the matrix. Here the first matrix is a 2 by 2 matrix, 2 rows, 2 columns. Second matrix is also a 2 by 2 matrix. If the order of the matrix are equal, only then we can add these matrices. You know how to add, right? How to add 5 and 2. 5 plus 2 is equal to 7. So, the same addition we are going to do here for the corresponding elements. Here in A, the corresponding elements are 2, 4, 3, 5 and in B, 1, 3, 6, 2 are the elements. Corresponding elements means the elements that are present in the first row and first column. Here it is 2 and here it is 1. We can add those elements. Now here 4 is the element that is belonging to the first row and second column in matrix A and 3 is the element belonging to the first row and second column in B. We can add these elements. Now we will be representing the matrix sum A plus B matrix inside square bracket. Okay, and the order will be 2 by 2. If you are adding two matrices of order 2 by 2, then the resultant A plus B matrix will have an order 2 by 2. Now we will add the different elements of these matrices. First element from matrix A, that is element belonging to the first row and first column. Here it is 2 and here it is 1. We will add these two. Now here element belonging to the first row and second column. We have 4. Here it is 3. 4 plus 3. Now the third element, that is element belonging to the second row and the first column. 3. Here it is 6. 3 plus 6. And the element belonging to the second row and second column. Here it is 5 and here it is 2. 5 plus 2. We are going to add these corresponding elements. That is, the A plus B matrix will be equal to, A plus B is equal to 2 plus 1, 3, 4 plus 3, 7, 3 plus 6, 9, 5 plus 2, 7. Simple addition can be performed. We have to add the corresponding elements. We have to check the elements of A and B. Check the first element and add them. Second element and add them. We can perform addition in this manner. Now, if this was a 3 by 2 matrix, here we will be having another row. We don't have elements to add from A. Here, there is no elements. In that case, this addition is not possible. You cannot add a 2 by 2 matrix and a 3 by 2 matrix because there are no corresponding elements in A. Clear? Clear what addition is? Next, we will do subtraction of matrices. Same as we did for addition, we are going to do subtraction. Here, A minus B. First step is check the order. We have the same matrices. For addition, we have taken the same matrices. This is a 2 by 2 matrix and this is also a 2 by 2 matrix. To find A minus B. How to find A minus B? We have to put a square bracket. Inside, we are going to fill elements. First element, 2 minus 1. Subtract. In that case, we did addition. We added the numbers, corresponding elements. Here, we are going to subtract the corresponding elements. 2 minus 1. Then, 4 minus 3. 4 minus 3. 3 minus 6. 3 minus 6. And 5 minus 2. 5 minus 2. This is how you will perform subtraction. Then, what is the matrix? A minus B. A minus B will be a 2 by 2 matrix. 2 minus 1. 1. 4 minus 3. 1. 3 minus 6, minus 3, 5 minus 2, 3. These are the elements of A minus B. Next, to find B minus A. If you add two matrices, A plus B and B plus A will be equal. But let's do B minus A. What about B minus A? We have to take elements of B and subtract the elements of A from B. That is here. 1 minus 2, 3 minus 4, 3 minus 4, then 6 minus 3, 6 minus 3 and 2 minus 5, 2 minus 5. This is what B minus A matrix is. What do we get? We will be getting a 2 by 2 matrix and the elements are 1 minus 2 minus 1, 3 minus 4 minus 1, 6 minus 3, 3, 2 minus 5 minus 3. What is the difference? Just we are changing the signs, right? For a matrix A minus B and a matrix B minus A, when you take, the elements are the same. What is the difference? Here 1 becomes minus 1, minus 3 becomes plus 3, 1 again minus 1, 3 becomes minus 3. Only this difference when you get A minus B and B minus A matrices. You understood the addition and subtraction of matrices? Yes? Let us take an example to do the addition and subtraction of matrices. Here, let A is equal to 5, 4, 3 minus 2, B is equal to minus 3, 0, 1, 4 and C is equal to 1 minus 3, 0, 2. We are going to add A plus B and subtract A minus B. This is the first question. Let's perform the addition and subtraction. First, A plus B. A plus B is equal to. Here, what is the first element? 5 and here it is minus 3. 5 minus 3. 5 plus minus 3 is 5 minus 3. Therefore, I wrote like this. Okay, then second, 4 and here it is 0. 4 plus 0. Here 3 and 1. 3 plus 1. Minus 2 and plus 4. Minus 2 plus 4. So, this gives us the A plus B matrix. A plus B is equal to, what are the elements? 5 minus 3. 5 minus 3 is 2. 4 plus 0, 4. 3 plus 1, 4. Minus 2 plus 4, 2. This is our required 2 by 2 matrix. Matrix is having the same order. This is a 2 by 2 matrix. This is also a 2 by 2 matrix. And we got A plus B. Some matrix also 2 by 2. Next, we will find A minus B. A minus B matrix. We should get a 2 by 2 matrix. First, 5 minus of minus 3. 5 minus of minus 3. We are subtracting this. 4 minus 0. 4 minus 0. Then 3 minus 1. 3 minus 1. And minus 2 minus 4. Minus 2 minus 4. Elements are 5 minus of minus 3. It becomes 5 plus 3. 5 plus 3 is 8. 8. 4 minus 0 is 4. 3 minus 1, 2. Minus 2 minus 4, that is minus 6. We get the required elements of matrix A minus B. A minus B is equal to 8, 4, 2 minus 6. This is again a 2 by 2 matrix. Clear? Next, the second one, here we have to find A plus B plus C and A plus B plus C. Inside the bracket, we are going to solve first. We know the BODMAS rule. BODMAS. Bracket of division, multiplication, addition, subtraction. So, addition is done later and the brackets are solved first. So, here we have the brackets. Inside the brackets, the content inside the bracket is done first. So, to find A plus B plus C, we have to first find A plus B. What is A plus B? A plus B is equal to 5 minus 3, 2, 4 plus 0, 4, 3 plus 1, 4, minus 2 plus 4, that is 2. Okay, this is A plus B. Now we are going to add C to this. We first did the bracket. What is inside the bracket? Now we are going to add C to this. A plus B plus C is equal to 2 is the first element from A plus B. 2 plus 1 is the first element in C. Then 4, here we have minus 3. 4 plus minus 3, 4 minus 3. Then 4 plus 0. Then 2 plus 2. We are getting a 2 by 2 matrix. What are the elements? Of A plus B plus C is equal to 2 plus 1, 3, 4 minus 3, 1, 4 plus 0, 4, 2 plus 2, 4. These are the elements of A plus B plus C. Next, A plus B plus C. We are going to find, that is, first we have to find B plus C. What is B plus C? B plus C is equal to minus 3 plus 1. First element. Here we have minus 3. Here we have 1. Then 0 minus 3. 0 plus minus 3 is 0 minus 3. 1 plus 0. 1 plus 0. 4 plus 2. 4 plus 2. We will be getting the elements of B plus C. B plus C is equal to a 2 by 2 matrix. The elements are minus 3 plus 1 minus 2, 0 minus 3 minus 3, 1 plus 0 1, 4 plus 2 6. Okay. Next, A plus B plus C. What is A plus B plus C? B plus C we got. What is A? Here we have first element 5. We have to add 5 plus minus 2. 5 minus 2. Here we have 4 plus minus 3. 4 minus 3. Then here we have 3. 3 plus 1. And minus 2 plus 6. These are the elements of A plus B plus C. First we found B plus C and adding A to this. We will be getting 5 minus 2. 3. 4 minus 3, 1, 3 plus 1, 4, minus 2 plus 6, that is again 4. This is what A plus B plus C is. This is again a 2 by 2 matrix. Now check these two matrices. The elements are same, which means we have A plus B plus C is equal to A plus B plus C. Okay, A plus B plus C is equal to A plus B plus C. We got the same elements 3, 1, 4, 4, 3, 1, 4, 4. Clear? Because we are doing addition, there is no difference to come. Okay? Additive identity. This word you are all familiar with. When you take a number 5 and adding a number to this should give us the answer 5. What is the number? Adding what number can give us 5 here? 0, correct. Adding 0 to 5 can only give us answer 5. 3 plus 0 is 3. 1 plus 0 is 1. In that case, the 0 is the additive identity. Yes, we have studied additive identity. This is a case of real numbers. Now, when it comes to matrices, I am taking a matrix A and adding something to this should give me matrix A. Okay, I am adding a matrix, let's say B. Adding this B to A should give me A. Okay, then this B is the additive identity. What should this B be? If I am taking the matrix A as 1, 2, 3, 4. Okay, adding some other matrix B to this should give me 1, 2, 3, 4. So here we have a 2 by 2 matrix and here we have a 2 by 2 matrix. Therefore, the matrix that is added should also be a 2 by 2 matrix. Now the elements. Here we have 1. To get 1, what should be added? When 0 is added to 5, we get 5. Which means 0 should be added, right? Only 1 plus 0 can give us 1. What about here? Here also 0. 2 plus 0 can only give us 2. To get 3, 3 plus 0 can give us 3. To get 4, 4 plus 0 can give us 4. In that case, what is this 0, 0, 0, 0? What is this matrix called? This is a 0 matrix or a null matrix. So, this 0 matrix or the null matrix is called the additive identity matrix. Okay, what matrix is added to the matrix to get the same matrix? That matrix is called additive identity. Okay, that is, if A and B are two matrices of same order, they should be of same order, and A plus B is equal to A is equal to B plus A, then matrix B is called the additive identity of matrix A. Now, if this is A plus B, we got A plus B is equal to A. Now, when do we take B plus A? What happens when you take B plus A? Here we have B as a null matrix, 0, 0, 0, 0, plus matrix A, 1, 2, 3, 4. What do we get? 0 plus 1, 1, 0 plus 2, 2, 0 plus 3, 3, 0 plus 4, 4. This is again equal to A. Therefore, A plus B equal to A is equal to B plus A. Then this matrix which is added is called the additive identity of matrix A. Okay. And for any matrix A, 0 or the null matrix, it is represented as O, is the additive identity of A, and this can be written as A plus O is equal to A is equal to O plus A. Here we have taken as a matrix B. We are sure that this matrix B will be a null matrix. Only if this B is a null matrix which is represented as O, only then in that case we will be getting A plus O is equal to A is equal to O plus A. Got it? Understood what additive identity is? Just take this simple example. With real numbers, we know what additive identity is. 0 is the additive identity. When it comes to matrices, 0 containing matrix. 0 containing matrix is a null matrix. Null matrix is the additive identity of the matrix whichever we need. Okay. Additive inverse, we are going to understand what additive inverse is. We know when 0 was added to 5, we got 5. This is what additive identity is. Now, we have to get answer 0. To the number 5, we are adding another number and the resultant is 0. What is the number? 5 plus some number is equal to 0. The number is minus 5. So, this minus 5 is what the additive inverse in case of real numbers are. Now, come to the case of matrices. Here, we are taking a matrix A is equal to the same example 1, 2, 3, 4, which is a 2 by 2 matrix. Okay. With this matrix A, another matrix B is added to get here 0. O is used to represent the null matrix. When we have 0 in case of real numbers, when it comes to matrices, it is a null matrix or a 0 matrix. The element should be 0, 0, 0, 0. Okay. Our matrix A. A is 1, 2, 3, 4. This 1, 2, 3, 4 matrix is added to another 2 by 2 matrix. We have to take a 2 by 2 matrix, right? Because only addition is possible when they are of the same order. We will be getting resultant a null matrix of order 2 by 2. What are the elements of this 2 by 2 matrix B? Here we have 1. Here we have 0. Okay. Adding some number to 1 should give us 0. If 5 plus minus 5 is equal to 0, then we know 1 minus 1 can only give us 0. What about here? 2 minus 2 can only give us 0. 3 minus 3 can only give us 0. And 4 minus 4 can give us 0. Then what are the elements of B? B is equal to, matrix B is equal to minus 1, minus 2, minus 3, minus 4. These are the elements of B. Now check this. Here the matrix A is equal to 1, 2, 3, 4 and B is equal to minus 1, minus 2, minus 3, minus 4. When minus 1 is multiplied with the matrix 1, 2, 3, 4, we got B. Yes, therefore this can be written as B is equal to minus A. Okay, B is equal to minus A. That is, we will be having A plus B equal to O and that will be equal to B plus A. B plus A means minus 1, minus 2, minus 3, minus 4 plus 1, 2, 3, 4. That will again give us O or the null matrix. Clear? If A and B are two matrices of same order and A plus B is equal to O is equal to B plus A, then matrix B is called additive inverse of matrix A. Clear what additive inverse is? We have taken B as the matrix. Now, additive inverse of a matrix A is obtained by changing the sign of every non-zero elements of A. Here we have just changed the sign. 1 becomes minus 1, 2 becomes minus 2, 3 becomes minus 3 and 4 becomes minus 4. What about the 0? If it is 0, for 0 we know there is no sign. 0 will be the same, 0 itself. That's why we have mentioned here non-zero elements. Okay. Next example 3, we will do an example. If A is equal to 8, 6, minus 2, 4 and matrix B is equal to minus 3, 5, 1, 0, then solve for a 2 by 2 matrix X such that in the first question the condition is A plus X is equal to B. Here first one, A plus X is equal to B. What is A? A is 8, 6, minus 2, 4 plus a matrix X. Matrix X will be a 2 by 2 matrix because only adding a 2 by 2 matrix to a 2 by 2 matrix will give us a 2 by 2 matrix. Order should be same. Yes, 2 by 2 matrix. That is, elements of B are minus 3, 5, 1, 0. We have to find the matrix X. X will be equal to, here we have B and A. Taking a normal addition subtraction process itself, here we are going to take A to the opposite side. It becomes B minus A. That is matrix B. Minus 3, 5, 1, 0, minus. Here it was plus. Plus becomes minus when it goes to the opposite side. Minus 8, 6, minus 2, 4. Then what are the elements of X? X will be equal to adding the corresponding elements. Here it is subtraction. Subtracting the corresponding elements. Minus 3 minus 8, 5 minus 6, 1 minus of minus 2, 1 plus 2 and 0 minus 4, 0 minus 4. X is equal to minus 3 minus 8 minus 11. Put the square bracket. This is a 2 by 2 matrix. 5 minus 6 which is minus 1. Then 1 plus 2, 1 plus 2, 3, 0 minus 4, 0 minus 4 is minus 4. The elements of X are, matrix X is equal to minus 11, minus 1, 3, minus 4. If you want, you can just check this. A plus X is equal to B. Here A, here we have 8 and here we have minus 11. 8 minus 11 is minus 3. Then 6 and minus 1. 6 minus 1 is 5. Minus 2 plus 3. Minus 2 plus 3 is 1. 4 plus minus 4. 4 minus 4 is 0. Just you have to check to find if the answer what you got is correct. Now the second one. Second is x minus b is equal to a. Then what is x? X will be equal to a plus b. What is a? Elements of a? 8, 6 minus 2, 4 plus b minus 3, 5, 1, 0. Adding them 8 minus 3. 8 minus 3, 5, 6 plus 5, 11 minus 2 plus 1, minus 1, 4 plus 0, 4. 5 minus 1, 4. These are the elements of x. We got x. Clear? Simple, right? We have to take this minus b to the opposite side, it becomes plus b. Let us solve some questions from exercise 9a. Here we have the first question. State whether the following statements are true or false. If false, give a reason. First question. If A and B are two matrices of order 3 by 2 and 2 by 3 respectively, then their sum A plus B is possible. Is it possible? Here A is a matrix of order 3 by 2 and B is a matrix of order 2 by 3. We know addition is possible only if they are of the same order. They are not of the same order. Therefore, addition is not possible, which means the statement is false. And the reason is that addition of matrices are possible only if the matrices are of the same order. Now, the second one, the matrices A 2 by 3 and B 2 by 3 are conformable for subtraction. Here, matrix A is of order 2 by 3, matrix B is of order 2 by 3. Order is same and then subtraction is possible, which means this statement is true. True. Okay. Now the third, transpose of a 2 by 1 matrix is a 2 by 1 matrix. Is this statement correct? No, right? In case of a transpose matrix, number of rows becomes number of columns. In that case, this should be interchanged. That is, here you have 2, here we will have 2 and it becomes 1 by 2 matrix. Just interchange the number of rows and columns. It is given that 2 by 2 matrix transpose is a 2 by 2 matrix, which means the statement is false. And the reason is that for a 2 by 1 matrix, the transpose will be a 1 by 2 matrix because there is an interchanging of rows and columns. Therefore, this statement is false. Okay. Now, the fourth one, transpose of a square matrix is a square matrix. Is that true? Yes, for a square matrix, if we take an example, we are taking a square matrix of order 2 by 2. Then what is the transpose? Transpose will be a square matrix of order 2 by 2, which means the statement is true. Next, a column matrix has many columns and only one row. Definition of column matrix. Column matrix has only a single column and many rows, any number of rows. That is, just the opposite statement is given, which means this is false. And the reason is just the definition of a column matrix. A column matrix should have only a single column and any number of rows. Clear? Next, problem 2, question 3 of exercise 9a. Solve for A, B and C if first question minus 4, A plus 5, 3, 2 is equal to B plus 4, 2, 3, C minus 1. Here it is given that these two matrices are equal. Matrices are equal when corresponding elements are equal and the order are equal. Here the order is, this is a 2 by 2 matrix. This is also a 2 by 2 matrix. Now we know the corresponding elements are equal, which means minus 4 will be equal to B plus 4, A plus 5 will be equal to 2, 3 and 3. 2 will be equal to C minus 1. From this we can find the values of A, B and C. Okay. Minus 4 is equal to B plus 4. Then what is B? B will be equal to minus 4 minus 4. That is minus 8. We got the value of B is equal to minus 8. Next, A plus 5. A plus 5 is equal to 2. Okay, here this is the second element. Here we have the second element in this matrix. Okay, A plus 5 is equal to 2 means A will be equal to 2 minus 5. that is equal to minus 3. Now to find C, here we have 2, here we have C minus 1. 2 and C minus 1 are equal. 2 is equal to C minus 1, which means C will be equal to 2 plus 1, C is equal to 3. Therefore, we got B is equal to minus 8, A is equal to minus 3 and C is equal to 3. Clear? So, this is our first question. Now, the second one. In the second question, we have matrix A minus B, B plus C, 0 is equal to 3 minus 1, 2, 0. Here again, this is a 2 by 2 matrix, 2 rows and 2 columns. This is also a 2 by 2 matrix. Okay. They are of same order. Now, the corresponding elements are equal. A will be equal to 3. Therefore, A is equal to 3. We easily got the value of A. Next, A minus B is equal to minus 1. If A minus B is equal to minus 1, we can find B. How? Substitute the value of A here. We have A is equal to 3. 3 minus B is equal to minus 1, which means taking this minus B to the opposite side and minus 1 to LHS, we get 3 plus 1 is equal to B, which means B is equal to 4. The value of B is equal to 4. Now, to find C, we have B plus C is equal to 2. B plus C is equal to 2. Then what is C? Substitute the value of B here. B is 4. 4 plus C is equal to 2. C is equal to 2 minus 4 or C is equal to minus 2. Okay. We got value of A is equal to 3. B is equal to 4 and C is equal to minus 2. Just we need to have an idea that if two matrices are equal, then their orders are equal and the corresponding elements are also equal. If you know if the corresponding elements are equal, then we can substitute and find the values of the variables here. Okay. Next, problem 3, question 5 of exercise 9A. If A is equal to 2, 5, B is equal to 1, 4 and C is equal to 6 minus 2, find first question B plus C, second A minus C, third A plus B minus C and fourth A minus B plus C. Okay. Here we need to find B plus C. B plus C. We know for addition of matrices, they should be the given two matrices should be of the same order. Here A is of the order 2 by 1, 2 rows and 1 column. What about B? B is also a 2 by 1 matrix. Okay. Now, when you add A and B, you will be getting a 2 by 1 matrix. We need to find B plus C. What about C? C is also a 2 by 1 matrix. When you add B and C, you will be getting again a 2 by 1 matrix. Okay. Now, what are the elements? B plus C, 1 plus 6. First element 1 plus 6. What about the second element? 4 minus 2. 4 minus 2. Then what is B plus C? 1 plus 6 is 7. 4 minus 2 is 2. So, we get a 2 by 1 matrix with elements 7 and 2. This is what B plus C is. Now, the second one we have to find A minus C. A minus C. What is A? We have A is equal to 2, 5 minus C. C is 6 minus 2. Okay. This is subtraction of matrices. When you subtract two matrices, the order should be same. Here we have a 2 by 1 matrix. Here also we have a 2 by 1 matrix. This is equal to, draw a 2 by 1 matrix with elements 2 minus 6, 5 minus of minus 2. Here we are subtracting and the element is minus 2. That is equal to 2 minus 6 minus 4, 5 minus minus 2, that is 5 plus 2, which is 7. Minus 4, 7 are the elements of A minus C. Now, the third one, we need to find A plus B minus C. A plus B minus C. What is A? Here we have A is equal to 2, 5 plus B B is 1, 4. C is minus C. 6 minus 2. Okay. Here we are adding the first two matrices A and B and subtracting the third matrices C from it. This is a 2 by 1 matrix. B is also a 2 by 1 matrix and C is also a 2 by 1 matrix. Which means A plus B minus C will be a 2 by 1 matrix. Okay. Then what are the elements? First, 2 plus 1 minus 6. 2 plus 1 minus 6. Second element, 5 plus 4 minus of minus 2, that is plus 2, which is equal to 2 plus 1, 3, 3 minus 6, minus 3. 5 plus 4, 9, 9 plus 2, 11. Okay. So, minus 3 plus 11 are the elements of A plus B minus C. Got it? Next, fourth one, we need to find A minus B plus C. Okay. A minus B plus C. What is A? 2, 5 minus B 1, 4 plus C 6 minus 2. Okay. We will be getting a 2 by 1 matrix with elements 2 minus 1 plus 6, the first element, and second 5 minus 4 plus and minus, it becomes minus 2. That is equal to 2 minus 1, 1, 1 plus 6, 7. First element is 7. 5 minus 4 is 1, 1 minus 2, minus 1. 7 and minus 1 are the elements of A minus B plus C. Clear? So, here we have done the addition and subtraction of matrices. We need to first check the order. If they are of the same order, only then we can add or subtract matrices. Okay. When you get the matrix, it will also be of the order 2 by 1. Here it is 2 by 1. Okay. It will be of the same order. Next problem 4, question 8 of exercise 9A. Given M is equal to 5 minus 3 minus 2 plus 4. Find its transpose matrix MT. If possible, find M plus MT, second MT minus M. Here it is said if possible. Why do we use this? Because adding matrices or subtracting matrices will be possible only if they are of the same order. Here we have a 2 by 2 matrix. Okay, when you take the transpose, you will again get a 2 by 2 matrix. Then addition is not difficult. Once if you have a 3 by 2 matrix, then the transpose will be a 2 by 3 matrix. In that case, we will not be able to add the matrices. Okay, here in this case, this is a square matrix, 2 by 2 matrix. The transpose will also be a 2 by 2 matrix, and addition, subtraction, everything is possible. We have M is equal to 5 minus 3 minus 2, 4. We'll first find M transpose. What is M transpose? How to find M transpose? We have to interchange the rows and columns. Here the first row is 5 minus 3. 5 minus 3 is the first row. It becomes the first column. 5 minus 3. Minus 2, 4 is in the second row. Second row becomes second column. That is minus 2, 4. This is our transpose matrix. MT is equal to 5 minus 2 minus 3, 4. Now, first question we need to find M plus M transpose. Adding these two matrices. M is 5 minus 3 minus 2, 4. And M transpose. M transpose is 5 minus 2 minus 3, 4. When you add them, first elements 5 plus 5, 10, minus 3 minus 2, minus 5, minus 2 minus 3, again minus 5, 4 plus 4, 8. Okay, M plus M transpose is equal to 10 minus 5 minus 5, 8. Now to find, the second question we are asked to find M transpose minus M. M transpose minus M. What is M transpose? We have M transpose 5 minus 2 minus 3, 4. 5 minus 2 minus 3, 4. What about M? M is equal to 5 minus 3 minus 2, 4. Now subtracting them. The first element will be 5 minus 5. Second element minus 2 minus of minus 3 plus 3. Minus 3 minus of minus again plus 2. 4 minus 4 is the fourth element. Adding them, 5 minus 5 is 0. Minus 2 plus 3 is plus 1. Minus 3 plus 2 is minus 1. 4 minus 4 is 0. So this is what M transpose minus M is. We got M minus. Next problem 5, question 9 of exercise 9A. Write the additive inverse of matrices A, B and C. Here A is 6 minus 5, B minus 2, 0, 4 minus 1 and C minus 7, 4. How do we get the additive inverse? Just take the elements and change the sign of the elements. We will be getting the additive inverse. So, the additive inverse of A is equal to, here A is a 1 by 2 matrix, 1 row and 2 columns. The additive inverse also will be a 1 by 2 matrix. Now the elements, here the first element is 6, therefore in the additive inverse the first element will be minus 6. Second element is minus 5, it becomes plus 5. Just interchange the signs. Okay, so this is the required additive inverse. To check this, when you add matrix A and B, if B is the additive inverse of A, then you will have a null matrix O. Just check the elements. Here we have 6 minus 6. 6 minus 6 is 0. Yes, we have to get a matrix of this form 0, 0. Then minus 5 plus 5 is also equal to 0. So this is the additive inverse. Next, second we have a 2 by 2 matrix. This is a 2 by 2 matrix. Additive inverse of B is equal to, what are the elements? We will be getting a 2 by 2 matrix as the additive inverse. Here the first element is minus 2. Here it will be plus 2. 0. In case of 0 we said sign doesn't matter. It is 0 itself. 4 minus 4 minus 1 becomes plus 1. This is the additive inverse. Now the third additive inverse of matrix C will be equal to, this is a 2 by 1 matrix. 2 rows and 1 column. What is the additive inverse? Additive inverse will be a 2 by 1 matrix. Elements, here the first element is minus 7. Here it will be plus 7. We have 4 here, then minus 4. So we got the additive inverse of matrix A, B and C. Just we need to change the sign. Negative will become positive. If a positive element is there, then it becomes negative. Only the difference. If it is 0, keep it as it is. Next, problem 6, question 10 of exercise 9A. Given A is equal to 2 minus 3, B is equal to 0, 2 and C is equal to minus 1, 4. Find the matrix X in each of the following. First question, X plus B is equal to C minus A. X is unknown matrix. Okay. We know B. B is equal to matrix 0, 2. C is equal to minus 1, 4 and A is equal to 2 minus 3. We can find X. Yes. So the first one, X plus B is equal to C minus A. X plus B is 0, 2 is equal to C minus 1, 4 minus A. A is 2 minus 3. So these are 1 by 2 matrices. A is a 1 by 2 matrix. B is a 1 by 2 matrix. C is a 1 by 2 matrix. Then X also will be a 1 by 2 matrix. X plus 0, 2 is equal to, subtracting minus 1 minus 2, that is minus 3. 4 minus of minus 3, 4 plus 3, which is 7. Minus 3 plus 7. Now to find x, we can take this matrix to the opposite side. Here it is positive, it becomes negative then. That is equal to minus 3, 7 minus 0, 2 equal to minus 3 minus 0. We get minus 3. 7 minus 2 is 5. This is what matrix X is in the first question. In first question, we got X is equal to minus 3, 5. Now, the second one, A minus X is equal to B plus C. A minus X is equal to B plus C. This is our second question. Okay. What is A? Here A is 2 minus 3. Minus X is equal to B is 0, 2 and C is minus 1, 4. Minus 1, 4. Okay. 2 minus 3 minus X is equal to, adding 0 minus 1 is minus 1. 2 plus 4 is 6. We got minus 1, 6. Now we need to find minus x. For that I am taking this minus x to the opposite side. Minus 1 and 2 containing, minus 1 and 6 containing, okay, that is 2 minus 3 minus, here it is positive, it becomes negative, minus 1, 6 is equal to x. Okay, 2 minus of minus 1, that is 2 plus 1, 3. Minus 3 minus 6, that is minus 3 minus 6 is minus 9. Minus 9, which is x. X is equal to 3 minus 9. Okay, x is equal to 3 minus 9. In the first question, we got x is equal to minus 3, 5. And second question, x is 3 minus 9. Clear? That's all for today. In today's class, we have understood what matrices are, different types of matrices, then the algebra of matrices and solved many questions from exercise 9A. Hope you all enjoyed this session. Do practice the remaining questions. I'll be back in next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.